I was waiting for you to remind me actually. A equals to 14,000.
I was like,
5,060 and P was 13,000 and T was 4 and R we need to find. We know the formula A equals to P
yeah,
times 1 plus RT. A is given 14,560. P is 13,001 plus R.
30,000.
We need to find T is 4. So we can divide 14.
1/3,
Sorry,
right? Isn't it 1/3
what is 1/3?
instead of 4? Like you,
No, 30,
because it's 4. Oh, it's
14.
4.
No, it's 14. T is 4, yeah.
Okay, and okay, that's where I did wrong.
What did you wrong?
Oh, I mixed it up. Yeah, I did 1 divided by 3 instead of 4.
No.
So I mixed it up with continuous or the compound, I
Mm.
guess.
Okay, then when you will
Right.
divide this 14,560 over 13,000 minus 1 plus 4R, and when you solve this 14,560 minus 13,000 over 13,004R, so it is 1,560 divided by this and 4R. So further 1560, it is 52,000 and R, and you can multiply it by 100 to convert it into percentage. So it
Yeah.
would be, see, I am giving you complete answer.
Yeah.
56 over 52%. So it is 3%.
Yeah. Got it.
Yahoo.
Thank you.
Right?
So basic formula, right?
Any other
E
question?
equal. I have a question.
Mhm. Yes. Yes, Anis.
So my question is for yeah, I wasn't there when you explained what N was. I'm sorry. So for the compound and continuous interest,
Give me
A
any,
equals.
give me please any particular question like constants or
So what will 1,500 grow if compounded daily at 6.75% interest for 10 years?
6.75% interest daily?
Yeah, daily.
No, it is not. Can I see the statement of the problem? Where is it?
It's in the PowerPoint number 2.
Slide number.
Hold on, I'm checking it right now. Slide number.
I have opened 3.2.
9. Slide 9.
Huh?
Slide 9.
29?
Yes,
Now,
I'm sending it on the.
this one?
Yes.
Yes, now. You mean,
So what exactly is N?
huh? What is
N.
N? You mean N for 9?
Sure.
This N. In this particular
Um,
what is the annual nominal rate compounded monthly for CD that annual percentage yield is? So,
I'm not talking about annual nominal rate. I'm talking about continuous compound.
so continuous compound. Give me any example of continuous compound. For example,
On slide 9, there's an example.
slide 9, like this.
But the only thing, it was compounded daily. So that's the only difference, but it's the same thing.
Yeah, but that is not continuous. If you want me to solve this problem, I can solve this.
Okay.
Find the amount to which $1,500 will grow. So 1,500 is our principal amount. If compounded quarterly, compounded quarterly means M is 4 at the rate of 6.75%. R is 6.75% for 10 years. Number of years are 10. So we need to use compound interest formula. So S equals to P times 1 plus I by N. N is N cross T. I is R by N. So N is 10 times 4, 40. R is 6.75% by M, 4. So you can substitute the values. P is 1,500, 1 plus 6.75% times R percent times N raised to power 40. If you solve this, you can get the amount which we will grow in 10 years. Is that clear? Anis?
Okay. Yes, it's clear. Now for the next question I have, we have an example. Let me. Yeah, I'm sorry. So the example on slide 12.
Same 3.2.
Yes, 12.
Yeah.
This is
Dollar.
inflation rate.
Yeah. Nothing changed. Now compounded daily. So you will say that.
Not this, sorry. I'm talking about the inflation rate. I don't know why it's different on this one. Computing the inflation rate. I don't think it's that slide.
Which slide number are you talking about?
It's 12 on my slide, but I don't think it's the same.
Are you talking about 3.3?
Can you take a screenshot and send it to the WeChat group and we can see it from there?
Yeah.
Or it's slide 15 on yours right now? On
Yeah.
I can see it, slide 15.
Oh, good.
Yeah, it's just the next slide.
Next slide.
Yeah, slide 15.
One?
Yes.
Yeah.
Mm-hmm.
So suppose a house that was worth $68,000 in 1987 is worth $104,000 in 2004. So its principal amount is 68,000, and in 2004 it grows up to 104,000. Assuming a constant rate of inflation from 1987 to 2004, what is the inflation rate? So how many number of years from 2004 to 1987?
17 years.
So there are 17 years. So 1 plus R, now you can take the 17th root in order to get the R. So that is the inflation rate. You can multiply it by 100. So it will become.
Formula that is used is A equals P
Yeah. 1 times
times 1
1 plus r.
exponent t.
Yeah.
Thank you.
Any other question?
Um, is it 1 plus? Yeah, 1 plus. 1 plus.
Is that all?
No, I.
Okay. No, 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 no. Most welcome. Most welcome. Take your time.
What do we use the annual percentage yield for? I don't
Yeah.
understand what it means.
It will be mentioned. Otherwise, you don't need to calculate.
Okay. Okay, well, that's all the questions I have for this one.
Okay. Anybody else? Anybody else? Constance? EA. Who is EA? Carolina, Lotta. I think EA is sleeping.
It's fine right now.
Okay. Constance,
Yes.
any question?
Sorry, sir. I didn't hear.
Tu comprends?
Question? Any
Oui, oui, oui. Yes, yes, yes. No problem. I'm following.
Okay. Okay. So I can jump into now sequences and series.
Yes.
Hmm. So last time we were studying, like if I write a sequence 2, 4, 6, 8, what type of sequence is this?
Arithmetic.
Yeah, its
10.
first one is 2.
Oh,
Its common difference is 2. So it is an arithmetic sequence. If I write another sequence 2, 4, 8, 16. Now, when we have a common ratio, when we multiply a specific number to get the next term, in that case, we say that this is a
Metric sequence.
sequence. And the number again in this first term will be called A1. First term of the sequence, and R is common ratio, like the number which we get by multiplying a specific number. Now I write some sequences, let's say 1, 3, 5, 2, 6, 18, similarly 1, 4, 7, 9, 1, 4, 7, 10, 5, 25, 1 to 5. How about the first one? Is it arithmetic or geometric or what?
Arithmetic.
Arithmetic. How about the second one? How about second one?
not.
Not what?
I don't know. Sorry.
It's geometric, like we are multiplying a specific number. 2 times 3 is 6. 6 times 3 is 18. So next would be 18 times 3, 54, and it will continue. So this is geometric sequence. It is geometric sequence with common ratio. Its common ratio is 3. Understand?
Mhm.
How about third one? Who can answer me for the third one?
Is that a 9 after 7?
Yeah.
I don't know.
It is not any
I thought it was at first because it would be plus 3.
sequence. It is not any sequence because we don't have any same common difference and we don't have any common ratio. Understand? So this is not
Mhm.
type of sequence. How about fourth one?
It's arithmetic. The
Yes.
the constant is
The common difference is
3.
3. How about the fifth one?
Geometric and the ratio is 5.
Very good. Geometric and the ratio is 5. How do we calculate, listen it very carefully, how do we calculate common ratio? We divide the previous numbers. For example, 6 divided by 2, 3. 18 divided by 6, 3. Similarly for this one, 25 divided by 5, 125 divided by 25. So this is how we calculate common ratios. So the general formula the general form of the general form of geometric series a1 a1 times r a1 times r square a1 times r cube, where a1 is first term of the sequence and r is the common ratio. For example, I write a sequence 2, 4, 8, and so on. The question is find 50th term of this sequence. A1 is 2, R is 4 divided by 2 is 2. You can check is it geometric sequence. 8 divided by 4, there is 2. So if you divide any two numbers, common ratio is same. So A1 is 2 and R is 2. We need to find the 50th term. So N is 50 and the nth term formula of our geometric series is R raised to power n minus 1. So this is your formula. Like arithmetic, the nth term formula is a1 plus n minus 1 times d. But for geometric sequence, the nth term formula is an equals to a1 times r raised to power n minus 1. Now we substitute the values. We find the 50th term, a1 is 2, r is 2 raised to power 50 minus 1. So 2 times 2 raised to power 49 or 2 raised to power 50 is the 50th term of this sequence. Understand?
No, why did you simplify 49 for 50? How does is it because the ratio is also 2?
No, no, no. It is the formula is n minus 1. N was 50 minus 1, so it is 49.
Right?
Understand?
Mm-hmm.
Then this is raised to power 1, this is 2 raised to power 49, it will be again 50.
Okay.
Okay.
So if the ratio was a different number, it would stay 49.
Yes. For example, I change the problem. 4, 8, or let's say 3, 6, 12, and so on. So first term is 3.
Yeah.
Yes.
I'm sorry. Can you explain the 50 again? Like 2 in the raise of the power of 49.
Mhm.
How do you calculate?
From this step to this step,
Yes.
okay. You see, this is 2 raised to power 1. This is 2 raised to power 4.
Yes.
Understand? Now, how we will solve them when bases are same, we add their powers. 49 plus 1, so it is 50.
50. Yeah.
When base is same, then we add their powers. Like, why do we say that 2 times 2 is 4? Because when base is same, its
It's
power is 1, its power is 1, and
yeah.
we add their powers, so it becomes 2 raised to power 2, so it is 4. Understand? So when base is same, we add their powers. So that is what we did. 2 raised to power 49, 2 raised to power 1,
Yeah.
2 raised to power 50. Or even if you don't do this, what you can do, you can first solve in your calculator what is 2 raised to power 49. Whatever you get number, you multiply it with 2, you get the same answer. Is that clear?
Actually not.
Okay.
So when you have like 2 and the power of 49,
Yeah.
it gets a small number, or do I write it wrong?
It is not a small number, it is a very big number. You can check it in your calculator.
Oh yeah. It's a very big number.
It's a very
And
big. Then you can further multiply whatever you get with 2.
I think the problem here is because the base is the same, but usually when the base is not the same, you do the power with the ratio and multiply it with the first number.
Yeah, that is
So
what
you
I'm
can
going to do.
sorry.
That is what I'm going to do. I take another example. Let's say 3, 6, 12. Carolina, is that it was Carolina? Carolina, is that clear?
yes,
Okay. So
3, 6, 12.
we take one more example. Now, first I need to see is it arithmetic series or geometric series. If it is an arithmetic series, then 3 plus 3, 6, 6 plus 3, 9. Next number should be 9. So it is not an arithmetic series. Let's see, is it geometric series? 3 times 2, 6.
Wait, are you writing now?
Sorry?
Mm-mm.
Oh, okay.
No,
You
no.
don't write because sometimes it's slow and yeah, sorry. Yeah, keep going.
Okay. So first I decide this one, is it an arithmetic series? If it is an arithmetic series, then 3 plus 3 equals to 6. The next term should be 6 plus 3 equals to 9, but the next term is 12. So it is not an arithmetic sequence. Understand?
Yes.
Now I see, is it a geometric sequence? First term is 3, then 3 times 2 equals to 6. Okay, next term is 6.
Yes.
So 6 times 2 is 12. Okay, the next term is 12. So we are multiplying a common number, which is 2. So it is an
Geometric.
geometric
Yeah.
sequence. You don't need to do whatever I just did. You can just do it in your mind. That was just for your
Yeah.
explanation. Understand?
Yes.
So first term is 3. We see what is common ratio. This is how we calculate common ratio.
Mm.
6 divided by 3 or 12 divided by 6. You can see if it is a geometric sequence, you can divide any two consecutive numbers. Your common ratio will be same.
Yes.
So we want to find the 10th term of this sequence, right?
Mm.
So if we want to find the 10th term of this sequence, then the general formula is a1 times r raised to power n minus 1. So
Mm.
n is 10, a1 is 3, r is 2. We can substitute the values. a10, a1 is 3, r is 2, n is 10 minus 1.
-1.
So 3 times 2 raised to power 9. Now first you will solve what is 2 raised to power 9 in your calculator, if you can help me.
512.
512, and then 512 times 3, 1536.
36. Yeah.
So the 10th term of this sequence is 1536. Is that clear?
Yes.
Okay. We take another example. For example, in the last lecture, live tutorial, we said that if the first term of the sequence is 3 and the fifth term is 48, right? Understand?
Yeah. Yes.
Yeah. So what is the arithmetic sequence and what is the geometric sequence? Now these are two different questions. Okay, what is the arithmetic sequence and what is the geometric sequence? I need everybody's attention. So first of all, we assume that if it is an arithmetic sequence, then the formula for arithmetic sequence is a1 plus n minus 1 times d. We are given a1 and a5. So A5 equals to A1, it will become 5 minus 1 times D. A5 is 48, A1 is 3, plus 5 minus 1 is 4D. 48 minus 3 is 4D, and it is 45 equals to 4D, and common difference is 45 by 4. Is that clear?
Yes.
So we got common difference 45 by 4, A1.
11
So general formula, the general formula for a arithmetic sequence is A1 plus D, A1 plus 2D, and so on. Now A1 is 3 plus common difference 45 by 4, 3 plus 2 times 45 by 4, and so on. Now we say that if it is a geometric sequence, if it is a geometric sequence, then we are given A1 is 3, A5 is 42, then the general formula or not the general, the nth term formula of geometric sequence is an equals to a1 times r raised to power n minus 1. So a5 equals to a1 times r raised to power 5 minus 1. So a5 is 8, a1 is 3, r raised to power 4. Now 48, 3 times 1 and 3, 6. So it is r raised to power 4. So now if you take the fourth root, 16 raised to power 1 by 4, and r equals to this. Further, you can write 16 raised to power 2 raised to power 4, 1 by 4. So r4 will cancel out with 4.
Sorry. Can
Yes.
you go through this again because you disappeared?
From which step?
Scroll up a bit.
Uh-huh.
From we didn't, or at least I didn't hear from. Can you scroll up?
Yeah,
Yeah, from the beginning. Can you take it again because you
Okay.
it froze.
no problem.
Thank you.
That was the question. What is the geometric sequence is if A1 is 3 and A5 is 48? So we are asked about geometric sequence. So we will use now the geometric sequence formula. An equals to A1 times r raised to power n minus 1. So we are given A1 and A5. I write A5. A5 equals to A1 times r raised to power 5 minus 1. So A5 is 48, A1 is 3, R is R, N is 5. So 5 minus 1 is 4. Now 48 divided by 3 is 16. 16 equals to R raised to power 4. We take the fourth root on both sides. Means I take the fourth root on both sides. So this 4 will cancel out with this 4 and it will become R equals to 16 raised to power 1 by 4. Furthermore, I can write 16 as 2 raised to power 4. So it is 1 by 4. This 4 will cancel out with this 4. I can get R equals to 2. Fine.
Can't we do square root, or does it have to be 1/2 instead of 1/4?
I did not get your point. What do you mean?
Here we have to take out the power. don't we have to usually use the square root to take out?
Have square, then we take the square root, but we don't have square root. We don't have square. We have 4. We have power 4, right?
Mhm.
Is that clear?
Mhm.
When we have power 2, then we take square root. But when we have power 3, then we take cube root. When we have power 4, then we take fourth root.
Oh, I'm good.
So R is this. First term was 3. So the general form of geometric sequence A1R square. Wait a second, I just asked that children to stop this music. Okay.
Mhm. Yo.
Okay. So A1 is 3 times R, 3 times 2 raised to power 2, and the sequence is 3, 6, 12, and so on. Is that clear?
Mhm.
So I revise this question once again. We were asked that what is, if you are given these two terms, A1 of any sequence and A5 of any sequence, it means you are given the first term and fifth term of any sequence, and you were asked that what would be the sequence if it is, if these two terms are the terms of arithmetic sequence, and what would be the geometric sequence if these two terms are the terms of a geometric sequence. Then for the arithmetic sequence, we use the formula for arithmetic series, and for geometric sequence, we use the formula for geometric sequence. Okay. Now, similarly, I take one more example. Let's say you are given two terms. A4 is, let's say, 16, and A8 is 512. You are asked what is arithmetic sequence and what is geometric sequence. So you will start for arithmetic sequence. The formula is a1 plus n minus 1 times d. An, if n is 4, we are given fourth term, it will become a1 plus 4 minus 1 times d. So a4 is, what is a4?
16.
Very good. A1 we don't know, so it is 3d. We call it equation 1, and then we substitute. If n is 8, then a8 is a1 plus 8 minus 1 times d. a8 is 512. a1 we don't know, so it is 7d. So we call it second equation. So we solve these first two equations. Solve equation 1 and 2 for A1 and D. If we solve them, we will get 16 minus 3D equals to 512 minus 7D. So minus 3D plus 7D, 512 minus 16. So 512 minus 16 is 490. 490.
496.
So D4 128. So the common difference is 128. You want to know the A1, you can substitute. You can put D equals to 128 in any equation 1 or 2. So if I substitute it in 2, A1, we want to know 7 times 128. What is 7 times 128?
896.
What?
896.
896. So 512 minus 896, what is it?
384.
300 and minus 384. So the first term is minus 384 and common difference is 128. So the sequence is, A1, A1 plus D, A1 plus 2D, A1 plus 3D, and it continues. A1 is minus 384 minus 384 plus 128 minus 384 plus 2 times 128. Is that clear? Is that clear?
Yes.
Now we solve the same problem for geometric sequence. Now we solve the same problem for, can you see it or is it too small?
I can see.
It's yeah, it's okay.
Okay, now for geometric sequence, the formula is an equals to a1 times r raised to power n minus 1. So n is 4. So a1 times r raised to power 4 minus 1. What is a4? 16. A1, r we want to know. So it is 3. So we call it equation 1. Now if n is 8, do you know why I am substituting n 8? Because we are given 8th term. So 8 minus 1, A8 is 512, A1 is not known, so it is 7. This is the second term. Now solve 1 and 2 by dividing. So if we divide 512 A1 r raised to power 7 divided by 16. So it will be A1 times r raised to power 3. So 512 divided by 16, do you know what is it?
32.
So r raised to power 7, r raised to power minus 3. So it is r raised to power 4. This is 32. 32 is 2 raised to power.
How do you find out
What?
what how many what's the power, like how to express it and to power something?
Because I have an idea that 32 is in some power of 2. For example, 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. So 1, 2, 3, 4, 5. So if I multiply 2 raised to power 5 is 32. So r raised to power 4.
But how can you calculate it if it's a bigger number and you don't really know,
You
like
don't
it's a very big,
you don't need to worry. For example, I don't know.
yeah,
With 32, you can simply take the 4,
32.
so that's
Ah,
your r. No problem. You don't need to solve it.
okay.
Okay. So the
Yes, thank you.
so the general formula A1 times R, A1 times R square, and so on. A1 was we don't know A1. We can need to calculate. So you can substitute this R raised to power 1 by 4 in any equation, 1 or 2. You can get A1 512 A1 times R raised to power 7. So 512 A1 R is 32 raised to power 7 by 4. So 512 divided by 32 raised to power 7 by 4. So that is your A1. A1 and R is 32 by 1 by 4. These are two awkward numbers, but when you will solve in exam, you will get with small and simple numbers. So because I am using examples, creating examples on my own, so that is why we got some awkward numbers, but normally you will get very simple numbers, but this is the procedure. Is that clear?
Yes.
Okay. So,
Uh,
mhm.
could you these solutions? Could you send it in a group chat later? Save it and send
Yeah,
it.
of course, I will save this everything. Actually, you know what I was thinking in next semester when we will have regular classes, what I will do, I will, I will bring this notepad with me in the class, and I will connect it with the projector. I will,
Oh, that's
sorry,
yeah, that's good.
yeah, I will write everything on my notepad, and you will see it on the projector. And
Yeah,
you instead of writing on whiteboard, I will write it on it. You will see it on the projector, and after that I can simply take the picture like here. I will export it into an image, and I will send it in the group, and you don't need to write anything in the class. You just need to focus whatever I will explain. Like right now, I will simply go into this option, export. I will export it into the image, and you will immediately get whatever I am writing. It will be saved.
that's perfect. Good.
Yeah, so I just realized that it is more convenient for me and for you as well, to not take the notes in the class, and it will be saved. And at the same time, we can record the, like right now I am recording it. So we will again use the Zoom. We will record every lecture so that you can listen it over and over. If you forget anything, you can just consult it rather than just delivering it once.
Yeah, that's perfect.
Yeah, I really like it.
Yeah.
And ultimately, thanks to my notepad, I hope it will keep working.
Yes.
Okay. So I think I am teaching only Carolina. Rest of the students are watching movie or something like that.
I'm here.
I have a question.
Sorry.
Are we going to talk about the sums this class, or do we leave it for next class?
Sorry,
Can we talk about the sums?
which sums?
Sum of geometric series.
Yes, I'm going to discuss now. And I want to see all of you so that I can realize you are active. Yeah, I hope my internet speed won't disturb me. Okay, so you have seen that, like, in arithmetic series, we have formula for sum. Let's say 2, yeah, let's say 2, 4, 6, and we say that find the find sum of first 10 numbers. If I want to find the sum of first 10 numbers, then that was the formula for arithmetic series. N by 2, 2a1 plus n minus 1 times d. So sum of 10 terms. So we were saying that n equals to 10, a1 was 2, d was, what was d?
2.
2. Yeah. So you can substitute it here. N is 10 by 2, 2a1 plus n is 10 minus 1 times 2. So 5, 4 plus 18, 22, 22 times this, and 110. So the sum of first term 10 terms is 110. One is very noticeable. You see, like in some formulas, if you want to find the sum, you will be always mentioned that find the sum of first 10 terms. Number of terms will be mentioned. If you can recall, I mentioned it in earlier lecture that we cannot find the sum of infinite series. We cannot find the sum of infinite sequences. So in that case, in that case, uh, we cannot find the sum. Similarly, we cannot find the sum of geometric sequence if the number of terms are not mentioned. For example, the sum formula.
I have a question about the formula that you just used.
Yes.
On the PPT, it doesn't add the D. It just says Sn equals n over 2 times a1 plus an.
That
Is
is
that
the
a different?
that is the same thing. See, in PPT it is written Sn n by 2 a1 plus an, right?
Mhm.
So n by 2 a1, what is an? The formula for an is a1 plus n minus 1 times d.
Oh, okay.
N by 2, 2a1 n minus 1 times d. So it is actually the same thing.
I'm sorry, what?
Same thing. You use this formula or the one which is mentioned in the PPT. Okay. So similarly, we cannot find the sum of infinite series and sum of geometric sequence. The formula for geometric sequence is a1 1 minus r raised to power n divided by 1 minus r. Understand?
Mm-hmm.
So, for example, you are given a series 2, 4, 8, and so on, we want to find the sum of first 10 terms. So n equals to 10. So it is a geometric sequence. So A1 is 2, R is 2. So sum of first 10 terms, so S10 equals to A1 is 2, 1 minus R is 2, sum of 10 terms divided by 1 minus 2. So what it would be, the sum of first 10 terms, what is 2 raised to power 10? Can you tell me please? 2 raised to power 10. Misha, what is 2 raised to power 10? Constance, what is
2048.
3000?
2048.
2014. It is not 2014, it is 2020.
Oh no, sorry. 1024. 1024.
1024 divided by minus 1. So it is 2 times minus 1023 over minus 1. So it is actually 2046. So the sum of first 10 terms of this geometric sequence is 2046. Understand? Now note, a very important note.
Oh, sir, can you scroll up for a second, please?
This one. You don't need to.
Yes.
You don't need to write. I will send all this, whatever I'm writing. You will get it immediately.
I don't. I remember better. I remember better when I write it down. So it's for me.
Okay. Okay. So note is we cannot find the sum of infinite arithmetic sequence and we can find the sum of geometric, say sum of infinite geometric sequence if R is between 1 and minus 1. So is that clear? We cannot find sum of infinite arithmetic sequence, but we can find the sum of infinite geometric sequence if R is between 1 and minus 1, otherwise not. Otherwise not. I explain these two steps with example. We cannot find sum of infinite arithmetic series. For example, I give you 2, 4, 6, and so on, and the question says find the sum of arithmetic sequence. It is not mentioning that sum of how many terms. If you see this problem, clearly here mentions find the sum of first 10 terms. But in this problem, we are not mentioned that we need to find the sum of how many terms. It means that we need to find the sum of complete series. So we cannot find the sum of infinite series. You can say that the answer would be sum does not exist. Now I take another example. Let's say 2, 4, 8. And it says that find the sum. Find sum of geometric sequence. Now you see that what is R? In that case, if it is a geometric sequence, you will see what is R. R is 4 divided by 2 is 2. So R is, you will say that since R is greater than 1, mathematically we can write it, since R is greater than 1, so sum does not exist. Again, you will say that sum does not exist. You see, I wrote it here clearly that we, for geometric sequence, we can find the sum of infinite geometric sequence if R is between 1 and -1, otherwise not. Now this condition prevails. Since R is not between 1 and -1, so we cannot find sum does not exist. Now I take another example. Let's say it is 64, 16, 4, and so on. It says that find the sum. So here I give you one more formula. Sum of infinite geometric sequence formula is A1 divided by 1 minus R. This is the formula when we need to find sum of infinite geometric sequence. So A1 is 64, R is 16 by 64, 1 by 4. So R is between 1 and -1. Understand? R is, you can see that we can find sum when R is between 1 and -1. And if you look at here, R is 1 by 4. 1 by 4 is less than 1 and -1. It is between 1 and -1. So sum does exist. So sum does exist. What is the sum? A1 is 64. 1 minus R is 1 by 4. So it is 64 over 3 by 4, which is 64 times 4 divided by 3. So sum is, you can solve this, 64 times 4, 256 times 3. Understand?
Yes.
So this is the sum of infinite geometric sequence. So we can, if you have any question, we can discuss it. Otherwise, I will give you one big assignment. I will try to give you this assignment with the solutions. You will go through from it. Otherwise, and next time in the next class, we will discuss that assignment, each question one by one. Is that clear?
Yeah.
Mhm.
And what about the one you gave us yesterday with the PPT? Which slide?
What was that? Can you tell me?
Yeah, that's I'm asking because I don't remember which slide it was about converting the problems.
That was fine. If you can do this, that was fine. Otherwise, the one which I will give you now, that is the important one related to sequences and series. So you can solve it. I will give you the solution as well. Maybe it would be difficult for you to understand because I just downloaded it from the internet because I sent it to the other class when they were in fundamental mathematics. Now they are in basic mathematics. So because my everything is in Shanghai in my office, I don't have anything. So I just asked one student, please send me if you have that assignment. So thanks to her, she sent me. I will send you that assignment with the solution. So it would be beneficial for you. You can have an idea how to solve the problems related to the real life application related to sequences and series. And in the next live tutorial, even in the next 2 live tutorials, we will discuss those assignments. I will give you in fact 2 assignments. We will discuss each question one by one, specifically those which you would not able to solve. Is that clear?
Yes.
Okay. Okay, then see you.
Thank you.
Yeah.
Thank you.
Bye.